Right now, in a clean room in Florida, technicians in white suits are finishing checks on a telescope almost nobody outside the space industry has heard of. It sits bolted to a test stand, wrapped in gold-colored insulation, its sunshield folded flat, like an umbrella that has never once been opened. Soon, it will ride a rocket to a point in space roughly 1 million miles from every living person on Earth. It has no nickname, the way the two famous telescopes before it did. It does not need one. It needs you to know two names that have been sitting in plain sight for years, unnoticed. One belongs to the telescope. The other belongs to a woman most engineers at NASA today could not pick out of a photograph. This is the story of both of them together. An instrument about to open the widest window on the universe any telescope has ever had, and the scientist without whom neither this telescope nor the far more famous one that came before it would exist. This channel exists to tell these stories accurately, without turning a real discovery into more than it actually is, so before this goes any further, it needs to be said plainly, this is not a bigger Hubble. It is not a rival to the newest infrared telescope already parked in deep space. It does a completely different job, and by the end of this video, you will understand exactly what that job is and why it took nearly a century for the right person to get any credit for making it possible. Start with the machine itself, because it is strange even before you learn who it is named for. Officially, NASA calls it the Nancy Grace Roman Space Telescope, and it is scheduled to launch on August 30th, 2026, on a SpaceX Falcon Heavy from Launch Complex 39A at Kennedy Space Center, the same pad that once sent astronauts toward the moon. The launch alone costs a little over $255 million, and that figure does not include the observatory riding on top of the rocket. Roman will not circle Earth the way Hubble does. It is headed for a gravitational parking spot called the second Lagrange point, roughly 1 million miles out, in the same general neighborhood where the James Webb Space Telescope has been sitting since early 2022. To understand why that matters, picture how Hubble and Webb actually see the sky. Both are extraordinary instruments, and both share the same basic limitation. They see a small patch of sky at a time in remarkable detail, the way a person might explore a museum by looking through a single keyhole cut into a locked door. You see one painting perfectly. You do not see the room. Roman's camera was built around a mirror the exact same width as Hubble's, 2.4 meters across, but paired with different optics that spread its view over an area roughly 100 times larger. If Hubble's keyhole shows you a single painting, Roman opens the whole gallery wall at once, and it still resolves each painting with something close to Hubble's own sharpness. That mirror has a strange history of its own. It did not start life as an astronomer's mirror at all. It was one of 2 identical mirrors donated to NASA in 2012 by the National Reconnaissance Office, the agency that builds America's spy satellites, because the government had manufactured more of that particular design than it ended up needing for orbital surveillance. A piece of hardware built to look down at Earth in secret is about to spend the rest of its working life looking outward at everything else instead. Roman has 3 jobs, and none of them is to produce another single beautiful postcard image of one nebula. The first is mapping dark energy, the unexplained force pushing the universe apart faster over time. Roman will photograph enormous numbers of galaxies across a huge share of the sky, tracking exploding stars called supernovae, and measuring how the light from distant galaxies has been stretched and bent on its way to us, some of it having traveled for billions of years to get here. Stacked together, that data lets scientists build a timeline of how the universe's expansion rate has changed across most of its entire history, something no single galaxy, however carefully photographed, can ever tell you on its own. By the end of its planned 5-year mission, Roman is expected to have captured the light of roughly 1 billion galaxies, far more than any telescope has cataloged before it. 1 billion is not a number anyone can actually picture, so picture it a different way instead. If you tried counting to 1 billion out loud, one number every second, never once stopping to sleep or eat, it would take you more than 30 years to finish. The second job is a census of planets around other stars, using a method that almost never gets talked about outside astronomy departments, called gravitational microlensing. When one star happens to pass almost directly in front of another, from our point of view, the closer star's gravity bends and briefly brightens the light of the star behind it, acting like a lens. If that closer star has a planet orbiting it, the planet adds its own small flicker to the brightening. A signature scientist can pick out if they are watching closely enough, for long enough. Unlike the more familiar method of watching a planet cross in front of its own star, microlensing can catch planets that orbit far out in the cold outer suburbs of a solar system. It can even catch planets with no star at all, drifting alone through the galaxy after being flung out of whatever system they were born in. Picture standing on Roman's side of one of those brief alignments, watching a single distant star quietly brighten and fade over a period of weeks, knowing the exact shape of that flicker is the only signature a planet you will otherwise never see is ever going to leave behind. Scientists expect Roman's microlensing survey alone to find more than 100,000 new planets. Named one a day, every day, without missing a single one, that list would take you close to 300 years to finish reading out loud. The third job is smaller in scope and enormous in difficulty. Roman carries an experimental instrument called a coronagraph, built to block the light of a distant star precisely enough to see the far, fainter planet sitting next to it directly. Not inferred from a flicker or a wobble in the data, but actually photographed. The starlight has to be suppressed by something close to 1 part in a billion. That is the rough equivalent of standing a few miles offshore, staring straight at a lighthouse and still managing to make out a single firefly blinking in the grass at its base. Nobody has managed that well enough from space to photograph a planet like our own around another star. Roman's coronagraph is a test for something bigger, and if it works, it will shape what the next generation of telescopes is built to attempt. NASA has already named that next generation. It is called the Habitable Worlds Observatory, a future flagship telescope also recommended by the National Decadal Survey process, explicitly meant to carry this kind of starlight blocking technology far enough to take a direct photograph of an Earth-like planet around another star. Roman's coronagraph is the test flight for that much larger ambition. Roman is also expected to hunt quietly for primordial black holes, hypothetical black holes that may have formed within the first fraction of a second after the Big Bang, long before any star existed to collapse into one. Nobody has confirmed that a single one exists anywhere. If Roman's data turns up even indirect evidence that they do, it will mean the infant universe was a stranger, a more violent place than the standard model of cosmology currently allows for. None of this makes Hubble or the newer infrared telescope obsolete. Both remain better at stopping to stare deeply at one single distant object for as long as scientists want to look. What neither one can do, structurally, is step back and survey huge swaths of sky quickly, because their cameras were built for depth, not breadth. To cover the same stretch of sky Roman photographs in one single exposure, Hubble would need roughly 100 separate pointings, stitched together afterward by hand. Roman was built for breadth on purpose, as a survey instrument first and a telescope second, which is a less glamorous description, but a more honest one for what NASA actually needs right now. Roman is not solely an American undertaking either. Space agencies in France, across Europe, and in Japan, along with Germany's Max Planck Institute for Astronomy, all contributed instruments, ground support, or funding to get it built, betting years of their own budgets on an American decision that, 3 separate times, nearly did not survive. None of this was ever guaranteed to happen. 3 separate times, budget proposals out of Washington tried to cancel this telescope before it left the ground. In 2018 and 2019, and again as recently as 2025. Each time, Congress or NASA's own leadership stepped back in and kept the funding alive. We will come back to exactly why this particular mission kept surviving votes that killed other proposals outright. But first, you need to meet the person this telescope is actually named for. You already saw her name go by, stenciled quietly into NASA's own paperwork for this mission. What you have not seen yet is her. She was born Nancy Grace Roman in Nashville, Tennessee, on May 16, 1925. Her father was a geophysicist. Her mother taught music. The family moved constantly through her childhood, chasing her father's fieldwork through Oklahoma, Texas, New Jersey, and Michigan before landing in Nevada in the mid-1930s. By the time she was 11 years old, in whichever town the family happened to be living in that year, she had already started a neighborhood astronomy club, meeting other children once a week to study the constellations out of borrowed library books. By 12, when her father took a position with the United States Geological Survey, and the family finally settled in Baltimore, Maryland, she had already decided on her own that astronomy was going to be her life. Almost everyone she told discouraged her, starting early. Her high school guidance counselor, when she asked to take a second year of algebra instead of another year of Latin, looked her over and told her that no proper lady took mathematics instead of Latin. Roman said, decades later, that this was the sort of reception she got most of the way through her early life. At Swarthmore College, the dean of women discouraged science majors outright, warning Roman she would want nothing more to do with her if she insisted on studying science or engineering. The astronomy department chair, an astronomer named Peter van de Kamp, was not much warmer to her at first, but he eventually relented, taught her himself, and let her use the college's telescopes and photographic plates for her own research. She graduated in February of 1946. She went on to the University of Chicago for her doctorate, working under an astronomer named William Wilson Morgan, who was reportedly so unimpressed by a paper she had written as a student that he refused to speak to her for 6 months. He kept supervising her research anyway. She earned her doctorate in 1949 with a dissertation on a cluster of stars known as the Ursa Major Moving Group. Then spent 6 years at Yerkes Observatory, working her way up from research associate to assistant professor while she studied the light spectra of stars. In 1954, she moved again into the radio astronomy program at the Naval Research Laboratory, where she eventually ran its microwave spectroscopy section and helped map part of the Milky Way using radio waves instead of visible light. None of that experience translated directly into astronomy from space, because at that point, nobody's experience did. What it gave her instead was a decade and a half of proof that she could run a serious research program, and by the time a brand new federal agency went looking for someone to build an astronomy effort from scratch in 1959, she already had the resume for it. In February of 1959, Roman left the Naval Research Laboratory for the newly formed National Aeronautics and Space Administration, joining as head of observational astronomy less than a year after the agency was created. Within a year, she was promoted again, becoming the first chief of astronomy in NASA's Office of Space Science, and the first woman ever to hold an executive position anywhere inside the agency. She was not managing an existing program. There was no existing program. NASA's entire space astronomy effort, essentially every satellite that would eventually study the sky from orbit, had to be built from nothing, by her, starting with a blank sheet of paper and a title nobody had held before. Picture that job for a second. You're handed a blank budget and told to decide, largely alone, which of the country's brightest astronomers gets a spacecraft built around their idea and which does not. For more than a decade, that was not a hypothetical for Roman. That was simply how she spent most of her Tuesdays. She was, by design, the person who decided which astronomy proposals NASA would fund and which it would not. She traveled the country giving lectures at university astronomy departments, explaining what the space program could realistically do and asking scientists what they actually wanted to study, then built NASA's project pipeline around their answers rather than her own preferences. Under her direction, NASA launched the orbiting solar observatories, the orbiting astronomical observatories, the Uhuru X-ray satellite, a series of small astronomy satellites, the International Ultraviolet Explorer, and eventually the mission that became the Cosmic Background Explorer. Almost none of those names are familiar to anyone outside the field. Every one of them changed what astronomers understood about the universe, and every one of them exists because a woman a guidance counselor once sneered at for wanting to study mathematics had, by then, spent a decade deciding how NASA's astronomy budget actually got spent. She did all of this without a personal computer, without email, and for a long stretch of her career without a calculator anyone would trust for serious work. Her tools were slide rules, photographic glass plates, and her own arithmetic, checked and rechecked by hand. The satellites she approved still flew anyway, on schedule, and the data they returned still holds up under instruments built decades after she signed off on the funding. But the achievement she would become best known for, the one that earned her a nickname she never much liked, was still ahead of her. The turning point came in 1968, after one of her earliest projects, the second orbiting astronomical observatory, returned results far better than anyone at NASA had dared hope for. Roman began publicly making the case for something much larger, a full-size telescope in orbit above the distorting blur of Earth's atmosphere, at a time when most of her colleagues considered the idea a fantasy. In 1971, she formally set up NASA's Science Steering Group for what was then called the Large Space Telescope, recruiting engineers and astronomers from across the country to help design it. Through most of the 1970s, she personally wrote testimony NASA used to justify the telescope's cost to a skeptical Congress, and she lobbied politically connected guests at private dinners hosted by NASA's own administrator, a man named James Webb. That name will come back around later in this story, in a way Roman herself probably would have appreciated. By the time the telescope she had fought for actually launched aboard the Space Shuttle Discovery in April of 1990 under the name Hubble, Roman had already been retired for more than a decade. If you remember watching that launch on the evening news, or reading about it in the next morning's paper, you were watching the payoff of a fight Roman had been waging quietly inside NASA for more than 20 years by that point, largely without her name attached to any of it. The space historian Robert Zimmerman later wrote that she had been the driving force behind a large space telescope from its earliest days. NASA's own chief astronomer at the time, Edward Weiler, went further, crediting her directly with selling the idea to Congress and organizing the astronomers who eventually convinced lawmakers to pay for it. The nickname that followed her for the rest of her life, Mother of Hubble, came out of exactly that record. Late in life, by most accounts, she grew uncomfortable with it and pointed out, correctly, how many other people had also given years of their careers to make that telescope real. She was blunt that way. Colleagues who worked with her described her as direct to the point of bluntness, someone who once shut down an entire research program the moment newer data stopped supporting it, and who never seemed especially interested in being thanked. Even the telescope she had spent a decade fighting for did not work correctly when it first reached orbit. Hubble's primary mirror had been ground to the wrong shape by a tiny, catastrophic margin, and for 3 years, It returned blurry images while engineers on the ground worked out a fix. In 1993, astronauts flew up and installed corrective optics, and only then did Hubble begin producing the images the world now associates with it. Roman was already retired by then, watching from the outside like everyone else, as the telescope she had made possible nearly became a punchline before it became a legend. She retired from NASA in 1979, in part to take care of her elderly mother. Retirement did not mean she stopped working. She consulted on the selection process for the institute that would eventually run Hubble's science operations. She audited computer programming courses at a community college in Maryland well into her later years, just to stay current. In the mid-1990s, she spent time at Goddard Space Flight Center running its astronomical data center. She recorded astronomy textbooks aloud for blind and dyslexic students, and she made a habit of visiting schools to talk with children, girls especially, about what a career in science actually looked like. Late in her life, she put it plainly, saying she liked telling girls by showing them her own life that they could become scientists and succeed too. In 2017, when a toy company released a Women of NASA building set that included a small plastic figure of her, she said it was, by far, the most fun honor she had ever received. She died on December the 25th, 2018 in Germantown, Maryland, after a long illness. She was 93 years old, 2 years after her death. In 2020, NASA renamed its next major space telescope after her. That is the same name currently stenciled onto the observatory, sitting bolted to a test stand in that Florida clean room, waiting on a launch pad that once sent astronauts to the moon. She never saw the announcement made. She will not be alive to watch it launch either, nearly 8 years after she died. And she never lived in a world where her own name carried anywhere near the recognition of the telescope she is most remembered for helping build for somebody else. Now, go back to the loop this story opened earlier and never closed. This particular telescope survived 3 separate cancellation attempts, while other NASA proposals, with just as much scientific merit, got cut without ceremony. The reason starts in 2010, when the National Research Council's decadal survey, the process the entire American astronomy community uses to rank its own priorities once every 10 years, named this mission its single top recommendation for the decade to follow. The first attempt to kill it came in February of 2018, buried in a White House budget proposal. Congress rejected it. A second attempt followed in March of 2019, and NASA's own leadership publicly reaffirmed its commitment to the mission instead of letting it go. A third attempt came in April of 2025, inside a new administration's opening budget request, and that proposal too was withdrawn within weeks. Each time, the scientific community pushed back hard, most visibly through the American Astronomical Society, which formally objected to the proposed defunding and pointed out that the mission's own estimated cost had barely moved in years. Congress, in its own budget language, said outright that it would not accept the cancellation of a scientific priority that the decadal survey process had already settled. Strip away the jargon, and the process is simple. Astronomers rank their own priorities as a community. NASA commits to respect that ranking rather than any single administrator's preference. That discipline is close to the exact system Roman put in place herself, decades earlier, back when she was NASA's first chief of astronomy, and there was no established process at all. The telescope now carrying her name survived, in the end, largely because of a system she is responsible for inventing. There is one more piece of symmetry worth sitting with before this ends. The telescope already parked out at that same gravitational parking spot, the one everyone already knows by name, is called the James Webb Space Telescope, after the NASA administrator Roman used to lobby at private dinners while trying to get her own telescope funded. It launched on December 25th, 2021, exactly 3 years to the day after Roman died. Hers is the quieter of the two instruments now sharing that patch of sky, and it took NASA nearly 5 more years to finally send it up to join his. Hubble itself is still working right now in the summer of 2026, 36 years after the flight Roman watched from the ground like everyone else. She is not here to see any of it. Not the anniversary, not the repairs, not the tens of thousands of research papers that have used its data since. The telescope outlived the woman who built the case for it. It was always going to. That is simply what a well-built machine eventually does to the person who fought hardest to get it flying. Back in that Florida clean room, none of this history is visible. There is only a telescope, wrapped in gold insulation, waiting for its sunshield to open for the first time somewhere it has never been. In a few weeks, technicians will close the doors on that room for the last time, and a rocket will take the whole thing away from every hand that has ever touched it. When that sunshield finally does unfold, roughly 1 million miles from home, Roman will spend the next several years doing something its own namesake spent her whole career being told, in various polite and impolite ways, that a woman should not be trusted to do. It will decide, on its own instruments, what is actually true about the universe, and scientists across the world will believe it. That is not a small thing to hand to any instrument, and it was not a small thing to fight for, not in an era when the fight itself was considered presumptuous coming from her. Every wide patient image Roman sends back over the next 5 years, and however many years beyond that, will be doing the same quiet, unglamorous work she spent her whole career defending. Not one dramatic photograph. Enough honest, carefully checked data to actually change what we know. The sky does not care who is allowed to hold the checkbook. It only ever rewards whoever is patient enough and stubborn enough to keep asking it real questions. If you want more of these stories about the people written out of the credits on the biggest discoveries in space, subscribe to this channel, because that is exactly the kind of story we go looking for. Somewhere out there right now is a kid being told, in some version of what a guidance counselor once told a girl in Baltimore, that this is not a field for people like them. 20 or 30 years from now, when the next telescope goes up to finally make full sense of everything Roman's data collects, there is a real chance that kid is the one who helped build it. That is worth coming back for. Thank you for watching, and for giving a few extra minutes tonight to a name most of the industry that depends on her almost let slip past unremembered.